So these are our section 10 notes, and it says more similar triangles. Throughout this unit, we've covered similarity, congruence, and these are unique situations with similar triangles that we want to cover, okay? So today we're going to talk about how we could use something called indirect measurement to allow us to find unknown lengths when it's impossible to measure the length needed. For example, if I have a really tall building or a really tall tree that I want to find the height of, there's a couple ways in real life application that we could do this. Okay, so indirect measurement is I'm going to measure without actually using a physical tape measure. Okay, so one way is to form similar triangles. Okay, because we know similar triangles are proportional. So the first thing we're going to discuss today, how to use indirect measurement, is we're going to use the shadow of the two objects. Okay. And the second is using a mirror, and that's a unique situation. Probably not super common, but it's definitely a possibility. Okay. So let's first talk about the shadow. When two objects both have a shadow created by the sun at the exact same time, you could know, if you know the height of one of the objects, you can find the height of the other. Okay? So let's imagine here that you know that you are 5 foot tall, just for simplicity here. And you have a 3-foot shadow. And there is a tree or a building outside that we do not know the height of it, but its shadow is 9 feet long. Okay? So some of you might look at this and say, oh, I see the scale factor. So the reason why we can find or use this shadow is that both objects are going to be standing perpendicular to the ground, right? So they have a right angle here. And then these objects here, the sun is up here, okay? They're both at the same angle to the sun, okay? And so these triangles are similar by the AA shortcut. So you can look at this and find your scale factor. And if you don't see that scale factor immediately, know that we can always set up proportions, right? So 5 over 3 must equal x over 9. And there's a variety of ways to set that up, okay? So if we had our scale, if we set cross products equal to each other, we would see 45 would equal 3x. Divide both sides by 3, x must equal 15. Okay? So let's look at one more example of that. This time, let's say that someone is 5.5 feet tall. Their shadow is only 2 feet long. This unknown tree has a shadow length of 6. Go ahead and set up a proportion for this scenario, please. And that proportion might look like 5.5 over 2 equals x over 6. So 5.5 times 6, 33. Divide both sides by 2. We know this tree is then 16.5 feet tall. Okay? So again, shadows are pretty easy, the easier one to tackle and kind of conceptualize. The next one is a mirror. Okay? So let's think about this. If you need to find the height of a very tall object, you can use a mirror. What we're going to do is we're going to place the mirror on the ground between you and the object, and then the person is going to walk backwards. Okay? All right, so let's say we have a really tall tree, and this picture's not in your note guide, so just kind of follow along here. So we have a really tall tree. We place a mirror on the ground, and then as a person would walk backwards, right? They're going to walk backwards until they're going to look down towards that mirror, and then when they see the tip top of the tree, that means that they are a similar scale factor distance back from the tree to create two similar triangles. So again, that idea of a mirror being on the ground might sound a little bit far-fetched, but before modern technology, this is something that people would do if they needed to know the height of this tree or building. Okay. So again, we have similar triangles because this person is 90 degrees standing perpendicular to the ground, and the tree is perpendicular to the ground, and then that mirror down here is creating congruent angles to the top of the eyes and to the top of the tree. Okay? So these triangles then would be like touching right here. All right? And again, they would be similar using the AA shortcut. So this scenario, let's say again we have a 5-foot tall person who is 7 feet away from a mirror. That mirror, though, is 49 feet away from this tree. Okay? So again, we have two similar triangles here. We could set up a proportion to solve. So 5 over 7 would equal x over 49. Set cross products equal to each other. 5 times 49 is 245. 7 times x is 7x. Divide both sides by 7. You can see that this tree then is 35 feet tall. Okay. Let's try one more example like that. So this time, we're going to measure in centimeters. This person is 175 centimeters tall. They ended up 200 centimeters from the mirror. The mirror was 600 centimeters from the unknown tree height. So again, we could have 175 over x maybe this time. They're in corresponding positions, equals 200 over 600. So cross products here end up as 200x equals 105,000. Divide both sides by 200, getting 525 centimeters tall. We divide by 200. Okay? So with those two ideas, those triangles are not overlapping. Okay? But there are also triangles that are similar, that they are sometimes overlapping, and this is the next big idea that we want to talk about. Okay? Whenever you're first being introduced to a concept like this, it's very important, and maybe as you get more familiar, you won't have to do this, but I'd like you guys to do this with me. We want to draw these triangles separately. So hopefully basically in this picture you see the two triangles, right? So we have our small triangle inside of the large one. So I'm going to redraw the large one, and then here's my small one, okay? So the large triangle has a length of 15 here on the edge, and this whole bottom piece here is 6 plus x, okay? And then the small triangle has a height here of 7, and its base is only x. Okay? So we're going to draw two triangles separately. Now, the problem's just like what we have been doing. Okay? Set up cross products. So 15 over 7 equals 6 plus x over x. So setting cross products equal to each other, 15 times x equals 42 plus 7x. Subtract 7x from both sides, we have 8x equals 42. When we divide by 8, x equals 5.25. Okay? So that's one example where you have to take this x plus 6 and add it together. A little different here on B. 26 is the whole length of x, or that whole side length of the large triangle, I should say. So on this problem, this whole side, the big, is 26, and the bottom is 18, whereas the little one is x and 5. Some students will try to label this as 26 plus x. Sometimes they'll try to label this as 26 minus x. But this line here is just trying to indicate this whole side is 26, so you don't have to combine them. Okay? So then, pretty straightforward here. Not a lot of math to solve. We just set it up maybe as x over 26 equals 5 over 18. Okay, so lots of different ways to set up these proportions. It's just however you are comfortable with that. 5 times 26 is 130. Divide both sides by 18. Okay, this is the length of 5. No. Sorry. Yep, I was looking at the wrong problem. 7.2. All right, and then the last big idea here is if you have a word problem, that you can draw the situation appropriately. So sometimes word problems, you need to draw them overlapping, and sometimes on a word problem, they need to be separate. Okay, so let's look at example 4 here. So on example 4, we have a lamp that's 20 meters from a bush that's 2 meters tall, and the height of the light is 10 meters. So when it's telling you that an item is a certain distance from another item, this is an overlapping picture. Okay? So you need to start with a picture like this. The lamp for the height of the light is 10, and it's 20 meters from the object. And this is obviously not drawn to scale, okay? If you wanted to extend your side out longer, you could. So that bush is 2 meters tall, and then the unknown length there is x. So then to solve this, our large triangle here is 10, and the base is 20 plus x, okay? Our little one is 2 and x. So setting up a proportion there, you might say 2 over 10 equals x over 20 plus x. Setting cross products equal to each other. 10x equals 40 plus 2x. In this case, you'd subtract 2x from both sides. And this one is x equals 5. Okay, so the length of the shadow by the bush is 5 meters long. All right, and the last example. On this one, it's an 8-foot tall bush casting a shadow. At the same time, a tree of an unknown height is casting the 10-foot shadow. This is a case where we're going to have to draw, they start separate. Okay, this is an example where these would start separate. So the mathematics on 4 and 5 aren't difficult. It's the idea of setting them up to get started. Okay, if you set them up overlapping when they shouldn't be, you're not going to get the right answer. Okay, or vice versa. So here you might have 8 over x equals 4 over 10. So 4x would equal 80. And that tree would have a height of 20. Okay, that concludes section 10 notes.